Okay, my name is Zining, and I'm a postgraduate in computer science from the University of Electronic Science and Technology of China. And I'm going to present a paper titled Injecting Event Knowledge into Pretrained Language Model for Event Extraction. And my presentation will include the parts. The first part, I will introduce the background of our research. The second part, the main idea and the work we have done. And then the experimental details and results. Finally is the conclusion and our future work. And we focus on the event extraction task. It's a common task of information extraction, and it's aimed to detect whether the sentence has mentioned some real-world events, and if so, we classifying event types and identifying event arguments. Here is an example sentence from the ACE 2005 dataset. We can see there are two event annotation in the sentence. The first event is the start position event triggered by the word hired. And the second event is the transfer money event triggered by the word paid. And each event has some entities as its arguments with specific roles. For example, in the first event, the start position event has two arguments, the person and entity, and the second event has four arguments, the giver, money, and so on. And the event extraction task is very important for many applications. For example, it can support some applications for decision-making, risk analysis, system monitoring, and so on. And the current challenges is that the deep learning, the deep neural network, and the small data set. The deep learning method has a lot of advantages over the traditional method, and many different variations of deep networks have been applied to event extraction tasks. But as a kind of supervised learning approach, its performance is highly dependent on the quality and quantities of the training data. But however, labeling training data is time-consuming, laborious, and also require professional domain knowledge, which limits the size of the available corpus. For example, the popular ACE 205 corpus, and we use this corpus in our experiments, it only has a total of about 600 documents, which is a very small quantity for the task to extract 33 predefined events and their arguments with 36 predefined rows. And a lot of work has been done to improve the extraction accuracy from a small set of labeled data sets. The common idea of current solution is the data expansion technology. It generates more labeled training data from external knowledge bases, such as the FrameNet, the WordNet, and so on, and then to use the both original and the generated data for the model training. But we argue that the data generating method is hard for event extraction because the events typically have a complex structure. An event can be mentioned by different triggers. Different events has different arguments with different roles. So in this paper, we propose a method to address the lacking training data problem by using the pre-trained language model. And so the pre-trained language model has made great success in recent years and has been a standard part of many NLP tasks It adopts a two-stage strategy: pre-train on the massive unlabeled corpus, and then fine-tune on the downstream task. And the BERT is a very popular pre-trained language model by the Google. So this is the background, the small training data set, the deep neural network, and the powerful pre-trained language model. So our work is inspired by language models. At the pre-trained stage, the language model benefits from the massive training text, but the language model is pre-trained using the general English corpus, while the downstream tasks usually require some task-specific knowledges. For example, in our event extraction task, we may need some event knowledges. So we further train the pre-trained language model with a carefully constructed in-domain corpus to inject event knowledge into our event extraction system. And this can be regarded as implicitly expand the training data, which is easier than data generation method we have talked before. And concretely, to verify our idea, we first build an event extraction system based on the pre-trained language model. Because the event have a complicated structure, so we have to carefully design our extraction model. And next, we build an unlabeled event training dataset from a large corpus, which is then being used to further train the language model to inject the event knowledges. And this is how we build the event extraction system based on the popular pre-trained language model. We extract event trigger and arguments in a pipeline mode through two BERT fine-tune strategy respectively. We extract event trigger by the token classification method. The trigger extraction aims to find the phrases in the sentence that most clearly express an event occurrence, and this can be seen as a simple sequence labeling task. We just encode the input by the model as a single sentence, and we feed the BERT's output, which is the last hidden layer of each token, to a classifier to assign an event types. And the argument extraction is relatively more complicated. We treat the argument extraction task for a sentence as several multi-class classification problems. Given a sentence, the event and the triggered word, the candidate's entities, we predict the role over the full set of the trigger entity pairs. And this table shows the examples used to extract arguments for the example sentence. And this slide shows how we build the event corpus for the further training model. We notice that almost half of the original data in the ACE 205 task comes from newswire and broadcast news. Therefore, to cover all the ACE events, we utilize the New York Times corpus. It contains over 1 million articles written by the New York Times. We first pre-process the New York Times corpus by manually selecting articles related to the ACE-defined event types. And concretely, each article in New York Times corpus is released with metadata, specifies a list of subjects mentioned in the article. And many subjects in the New York Times corpus have a very strong relation with the ACE predefined event subtypes. we just select the news document with the most similar topics to each event type and form our corpus, and this table shows the details. So we ended up with almost 300,000 articles, including 150 million words as our event corpus. And this is the experimental details and the results. Our baseline is the event extraction system based on the original BERT model. We direct fine-tune it from the model released by the Google. We can see that it already achieved a fairly considerable score. We achieved 73% F1 score on trigger classification and 58% F1 score on argument extraction. And this shows that the power of pre-trained language model for the event extraction task. And after the further updating the model using our event corpus, denoted by the event BERT, we observe that the model achieved better performance over all metrics on both trigger and argument tasks. We can see that it gains about 2% improvement on both the task. And yes, there are some experimental details. We fine-tune the model on a single GPU because the fine-tune is relatively easy. And we do the further training on a cloud TPU, and we train it for 200,000 steps of batch size of 384. And the last part is the conclusion. And in this paper, we propose an event extraction system based on the pre-trained language model for both the event trigger and argument extraction. And we use different fine-tune strategies that is best for each task. And then we explore a new way of using external corpus for event extraction task, and the further training the language model rather than generating new training data than the previous method. We also build an event corpus from the New York Times corpus for ACE event extraction task. And we believe that the idea of injecting in-domain knowledge by further pre-training the BERT can be helpful to other different NLP tasks, just like the event extraction, in which generating extra training data is hard and painful. But however, one major limitation is that a corpus that contains specific in-domain knowledge is required for each different task. And for ACE task, building such a corpus is easy as the ACE dataset involves just common topic. But this is not the case for many other tasks. Therefore, one possible direction for future work is to minimize the cost of constructing the in-domain knowledge corpus when applying our method to other tasks. And one way to achieve it would be to transfer knowledge from one task to another. And we just think that the corpus we build, the event corpus, can also be used to some similar tasks, for example, the KBP event extraction task, and we may verify our idea in the future. And thank you very much for listening.